Hello, a little while ago I was demonstrating this. It's a DPS375SP digital timebase corrector. But to fully test it I should use a vectorscope. And I did mention that I don't have room in my rather small workshop here for a big vectorscope like the one I've got downstairs. So,
Special delivery.
oh, thank you very much, but I'm not really sure how this is going to help me.
They say good things come in small packages.
Okay, well, we have some paperwork. So this is from Dan. It says, please find enclosed the TDS3VID application module for Tektronix TDS3000 series scopes. It adds various video specific features to the scope, notably a vector scope and triggering on specific lines. All right. Note that the scope supports 4 application modules in the top right corner, so that's this scope here, the 2 front face in the cutouts, and then there's 2 that you can't see hiding the other way. Well, I'm only going to have 2, so that's fine. Right, let's slide this out. So the other one I have in here is a TDS3FFT fast Fourier transform module. So there's a blank to come out. I'll try not to lose it. Can I store the blank in the back? Oh yes. Now the B series of these scopes I believe have all these modules built in, but the A series ones you have to actually plug them in. How exciting is this? So we'll plug that in and find out how to use it. To display the video quick menu, push the quick menu panel button, then the menu button. I've never done this. Okay, so let's try it. I've never even seen a quick menu button. Where's that? Quick menu. Okay. Then the menu button, that's the regular one. To select display and video quick menu. Vector scope and video picture accessible from video quick menu. I don't know what this means. Aha. Right, here there's a soft button menu. It didn't mean press that one, it meant here. Scope or video. Now we understand.
Hey Dad, according to ChatGPT, if your firmware version is below 3.3, the vectorscope display feature won't show up. What version of firmware do you have?
Right, so we're working on the assumption that I messed up on that disk or it was corrupted, one or the other. What does the instructions say will happen after 2? Because it's done a reboot. Oh, firmware replacement in progress. Please wait.
Alright.
Do not switch off.
Ah yes. Instrument may or may not reboot itself once disk 2 has been loaded.
Aha.
In any event, wait until your prompt is input.
There's a friend of mine who's also got one of these oscilloscopes. I'll keep these floppy disks in case he wants to update the firmware on his and he hasn't done it already.
Yeah.
It's not had a factory calibration in a very long time. Probably, it may never have had a factory calibration. Okay, the history behind this oscilloscope. I don't think I'm going to be treading on any toes to tell people this. I worked at Nortel in Paignton and they used quite a few of these on test rigs. Which is why this has got a GPIB port at the back, because a lot of the equipment was connected with GPIB ports. And one of our suppliers had an oscilloscope of the same model, so this one belonged to the supplier. It did not belong to Nortel. And when Nortel moved on what they were manufacturing and where they were manufacturing it, the supplier shut down. And I worked with that supplier and a friend of mine to catalogue a lot of their surplus equipment and sell it on eBay, and I was offered payment to do that, and I said I'd really like this oscilloscope because I wanted a decent oscilloscope. So he said, well, I'll do a deal on it, but I can't give it to you because it was too valuable. So I paid £400 for this oscilloscope, and at the time they would normally fetch double that. So I was able to get an oscilloscope for a price I could afford. And what was really sad is my old analog oscilloscope. I sold that on eBay, and I put it in a box. And because Nortel were chucking out lots of boxes, I stuck it in a box from a computer, a Sun workstation. Yeah. Unfortunately, the courier company left this box, which looked like it contained a PC, because people don't know the difference between a PC and a Sun workstation, on the doorstep of the person I'd sold the oscilloscope to. And when he got home from work that day, it had gone. So my oscilloscope got stolen. We never found out what happened to it. That was all very sad.
I think actually maybe 0 bugs 0 probably just mean 0 bugs.
I don't think so, because it had an exclamation mark after it before. Right, this is taking a while, so should we come back later? It says, signal path compensation is successfully completed. Press menu off to remove this message. Oh, good. We have vectorscope here as one of our options. Fixed it. Excellent. When we went display, we had this bit, but we didn't get vectorscope on. And now we have to select whether this is 75 or 100% color bars. But that isn't anything like the image I'm expecting. Video picture on. We should be able to get something else. Okay, video picture on. We can do that. Ah, you know what? I must be in the wrong. I must be in 525. Why does it default to that? Standard definition 625 line. That'll help a lot. PAL. Okay. And this is the thing where I can display any given line. Like 24 is my favourite because you can see the beginning of the video information there. Okay, so now I can go display vectorscope. By connecting to the correct signals, PB and PR, I think I have a vectorscope display, but it's quite noisy and everything slips down, which may be a genuine case of a problem with the color bar generation here, or could be that something's not quite set up here, but we're not really landing on the dots quite as we should, and there's lots of jitter, so don't have things quite set up. What do you think I've got wrong? Of course, one thing that could be unhelpful is we've got a direct BNC connection here. We could have an impedance mismatch on that. Don't think that's the cause, but I suppose I could put the oscilloscope probe into the BNC socket. Yes, let's try that. Okay, that has helped. So we may have had a bit of a problem with signals bouncing up the BNC cable there, but still all the colours are shifted down from their proper locations. Which is not something you can adjust on the time-based corrector, because of course this is its own internal test pattern, so its adjustments are only for signals that it's processing, not for a color signal that it's generating. Okay, I got it working. It's necessary to connect channels 1 and 2 to the two signals, which are PB and PR on the component outputs from the time-based corrector. Then I was able to get these correct. You do have some, sort of adjustment here. It's not like a real vector scope where that the signal levels are correct. In this case, if you make adjustments to your signal levels, you're going to mess up what you see. So yeah, it's kind of a vectorscope. The lands aren't perfect, but that could be as much due to the time-based corrector itself as the instrument we're reading it on. And they're pretty close. So it is working. I did this with the scope probes, and they're sort of round in the back. So that's a highly non-ideal arrangement. Of course, what would be better would be to have used BNC cables straight through to here with 75 ohm loads at the end, but that's not something I have to hand. So yes, I got it working, but you can't apparently display the video. If I go picture on, I don't get a picture, and it switches itself off again. Picture on, and it goes off again, because I believe you need to use the composite video to get the picture, and I'll do that in a moment. And having adjusted that, I've now lost my settings here for the vectorscope, so I need to put that back to, I think it's 200 millivolts on both channels. Okay, I've adjusted it back pretty much, but the fact that there is variability here does make you think that it's, you know, not really the same as a true vectorscope. So having found that the vectorscope is possibly of limited use when really you needed to be able to do composite video, at least you do get the sophisticated triggering, for example triggering on a given line number. But I read in the blurb about updating the firmware that that feature comes free without this. So let's try it. I'll switch this off and see if we get that advanced triggering now without having the video triggering module installed. So that feature is added as a freebie with the firmware update and does not depend upon this. Okay, so I configured it to display the picture on. It says in the manual it's black and white, fine, there's no color decoder, but there's a lot of noise running through that and I don't know why. And actually even in the user manual it looks pretty rough, so that probably is about as good as you get. So having got the vectorscope working, let's actually do what it was intended for. What I wanted to do, the time-based corrector that we've been working on, we've been using its internal signal generator to get the vectorscope signal. But what we really want to do is put a signal through this time-based corrector and check that when I twiddle the controls for various functions that we can see the vectorscope's response changing as per, for example, the chroma level and phase shift and other such settings. So the ideal way to do that would be to feed a good test signal into the time-based corrector under test, and for that I'm using another time-based corrector of essentially the same model. So we'll be using the output from this into here, but I'm not going to use any old output from here. The whole point of all this, the whole reason for these time-based correctors being so valuable is that they work with the Dub signal, which is available from most, not quite all, professional U-matic video recorders. And for that you need the exquisitely rare and hard to get hold of Dub cable. So we have one of those. So it uses this connector. One of the problems being these connectors, you can't really get them anymore. They're very hard to source, and I had to sort of make one a while ago. So we'll connect from this machine, which will be set to output the color bar signal, into our one under test using Dub, and also you need to connect with a BNC cable the composite video as well, because I think it takes the color burst signal from that. So I'm going to hook all this up and then get hopefully the vectorscope set up again, and then we'll go from test signals that are generated in the machine under test to test signals that are generated via this one and fed into the time-based corrector under test. Okay, today I've hooked it up again. I've had nothing but trouble trying to get a reasonably stable vectorscope image from this. It's been really hard. I've changed to the scope probes that belong on the cheaper oscilloscope, and I don't think that actually helped, but at least it's consistent. So at one point I was having a bit of trouble with the HP scopes, so maybe these probes are better or in better condition. Anyway, I've kind of got a vectorscope, but I don't think it's as good as what I managed to achieve yesterday at one point. But anyway, that is with the TDS DPS 375 SP, which is under test, doing its internal signal. So there it is, it's in test mode. This machine is feeding that one via Dub. So and it's also set to bars. So if I now go to process, we should see, instead of its internal signal, we'll see the processed one. And we can see that on the TV as well. So that's from this test generator, and that's from the other one. You can see a subtle difference in timing, I think. See, so that's process, bypass, I'm not sure why that's in black and white, and test. Oh yes, in bypass, I think that's composite only, that's why. Just a feature of these machines. So now we're looking at the signal output from this one. Right. And it is a bit scrappier, it has to be said. That is nowhere near as good as its internal signal. Its internal signal is there, but I'm still not that pleased about that waveform. And the processed one is there. And it appears a little, well, noisier. If I now adjust some of the controls, so we're in process, so I should be able to set chroma level and wind it down. And we'll see that on the monitor. All the colour should disappear, yep. And indeed, we see that here. Still got the noise on it, but it's all on the no chroma position. And if I turn the colour back up again, out it goes. And 0 point is there. But why all this noise? Do you believe the noise, or do you think it's just a hooking up type problem? Let's try chroma phase. I'm not sure if that'd be visible on here, but let's try it. Oh yeah. So I swing chroma phase backwards and forwards, and yes, you can see that. And the interesting thing about that is, on the monitor, you'd be hard pushed to see any difference as I swing chroma phase backwards and forwards. Just nothing really happening. But the vectorscope is a much more sensitive measurement than just your eyes on a monitor. And I switch it back to the 0 position for chroma phase. There, I think it is. Black level, will we see black level? No. No, you don't see that on the vectorscope. About chroma level, Y level. So that's brightness effectively. And again, you don't really see that. Y level probably only affects the Y output, which this scope isn't even connected to. And we can change timing as well, horizontal and vertical color timing. We could also do things like change the horizontal and vertical color timing, but you won't see that on this kind of pattern, and I'm sure you won't see it on the vectorscope either. So my question would be, why is its internal test signal somewhat cleaner than the processed signal from the other time-based corrector? Does one or other machine have a fault, or is it just a hooking up type problem, or is that what you'd expect? But there's the test signal from its internal generator. None of them are pretty though. As a vectorscope, it doesn't seem to be working that well, and it could be some sort of cabling issue. And it should be said that what I had done this time is connected up loads. So I know it's supposed to be 75 ohm. The resistors I had to hand were 180, so I used pairs of those. So we've got about 90 ohm load, which is probably close enough that the outputs are feeding a proper load. So I don't know why we're getting such grubby response on the oscilloscope as a vectorscope. Okay, this is the second time we've looked at a plug-in module for this. The other one was the FFT, which turns this into, well, fast Fourier transform turns it into a time domain display, in other words, a spectrum analyzer, like this. And I've pretty much found that this is a better spectrum analyzer than this. So that was a little bit disappointing. It sort of works, but this does a better job. And now we've found that with the 3VID module, that it enhances triggering functions. You can trigger on a line, but with the new firmware in here, you can do that anyway. So it can turn it into a vectorscope, but it's a little bit limited, and I'm not sure how far I'd trust it. And you can also display the actual image on here, which could be handy if you're working on things, but on video, but the image quality wasn't really usable, and even the one that it shows in the manual isn't really usable. So I don't think that's terribly useful. And anyway, even as a vectorscope, it insists on 2 channels. So you could only use this in a situation where you have a component output. So for the composite video, you can display the image sort of on the screen, but there's no Chroma decoder in there, there's no color burst decoder, it can't do true color decoding in there, which is why you can't feed it with composite video and expect it to work as a real vectorscope like the ones I have in the studio. So as a vectorscope it doesn't really work, I don't think. In my humble opinion, it's not terribly successful. So do you think Tektronix were not really being entirely fair with these plug-in modules? On the later version of this, I understand that the firmware was built in and you had to pay to switch it on, and you can hack it and have all these features included anyway. Don't quote me on that because I don't have the B version of this. This is the A version with the floppy drive. But it was worth anyway using that floppy drive to update the firmware on this, so that was a bit of a bonus. I mentioned at one point that we were getting a 0 bug error message on here, and that's due to failure of the Dallas Semiconductor real-time clock in here. I'm going to have to look up which model of real-time clock it uses and where it is, if it's accessible, or let me know if you have already done that. You can get modern replacements to those on eBay and similar. Would one of those modern replacements be relatively straightforward to install in here? If anyone's already done that, let me know and we'll do that, get rid of that error, and then we can at least hold the real-time clock information properly in this. I understand that it doesn't hold calibration data, fortunately, so it's not a major disaster that it doesn't work, but it does mean that all the timestamps are wrong on the floppy disks and stuff like that. Right, I hope you've enjoyed what we've done here today. It's been quite unusual and interesting, I think. I'll do plenty more content on audio and video technology in the near future. Bye for now. The whole purpose of this test was to look at the output from this timebase corrector, which is the one I've been testing, when fed with this one, which is believed a known good one. You might ask, what happens if I swap things round? So I go from this into this. do I get a better vector scope response? Only one way to find out. Okay, I've set that up, so we now have this one, the one we were supposed to be testing, feeding into what we believe is a known good one. They're both in test mode at the moment, and we have that vector scope, which is much the same as it was from this one, a bit grubby, but you know, you can see it. So now, and I've not tried this yet, let's set this one to process. The image shifted a tiny little bit. And again, we get that somewhat grottier response. Did we think that maybe that's something to do with timing? Phase, chroma phase. So if I adjust chroma phase, yeah, they come in a little bit with a chroma phase adjustment. So that's sort of saying that the dub cable connection is introducing a small chroma phase error. Maybe that is what this is telling us, and it's not supposed to do that, but it could just be a limitation of the system. So the good thing is that downstairs I have a real vectorscope. It's a digital one connected to the SDI port of my digital Betacam machine that is routed from U-matic. So if I play U-matic tape on there, which has got colour bars at the front, I can check the chroma phase of every tape and get it right using the timebase corrector. Right, here we have the Videotek SDI type vectorscope, which is connected to this digital Betacam, which is presently outputting its own colour bars. And of course, it's an all digital system, that's perfection on a stick. So now I'm going to get colour bar generation from the timebase corrector, which is underneath here, and have a look, see what that looks like on here. But of course that's not using the dub cable, that's using the YUV cables, or the component cables from the back of this feeding into the digibeta. But let's see what it looks like. Right, so that's the analog output test signal going into the digibeta from this timebase corrector, which is a little hard to see, but it's got its output set to test mode there, and the vectorscope is, again, perfection. Oh, have we got the wrong, yeah, we may have the wrong, there we are, 75, there we go. Well, is it perfect? Not sure if it's 75 or 100% modulation. Neither seem to fit. Oh, okay, so that may have its complications as well. And they're pretty close.